Hello and welcome to the LINBIT community meeting. My name is Michael, and this is an open community meeting where every quarter we open the meeting to public where you'll receive updates from our latest LINBIT software developments and have the opportunity to get answers to any of your pressing questions that you may have. If you have a question, just raise your hand in Zoom or ask it in the live chat. Let's get the ball rolling with some developer spotlights to find out about the work that's being done on LINBIT software. First up, we're going to talk about DRBD Reactor with Roland. So Roland, the floor is yours.
Thank you. Do you hear me? Yeah, perfect. Okay. So what I want to talk about is a bit on a new behavior we implemented in DRBD Reactor, especially in the promoter plugin. So bit of theory before I give you a quick demo about it. So how does it usually work? You define your services, then DRBD Reactor starts those services. It's active on one node. DRBD has a quorum there. Everything is fine. is fine. Then something happens, like the network goes down, and the currently active node loses connection to its peers. So it loses quorum. And what we then usually do is we immediately stop all the running services on that node, demote DRBD, and hope that some other nodes that still have quorum will be able to start the service. But what if you have a service that takes a very long time to start? For example, could be a database that takes minutes to start. And then further imagine you lose the connection in the network. You immediately stop the services, but the other nodes also don't have any network connection, so they don't have quorum and they won't be able to start the service because, yeah, they don't have quorum. And then the network comes back, nodes connect again, and then one node, they again have quorum, and one node will start the services. And then you hit again the penalty of, I don't know, 5–10 minutes of starting the database. But probably one could do better by just freezing the resource on the node that was active. So it was active, it has its resources frozen, connection is gone, quorum is gone, but the other nodes are also not able to get quorum. Then at the later point in time, they come back, they connect to the old active node, and then we just unfreeze the service and can continue with the service immediately without needing it to start from fresh. And that's what we call freeze support for DRBD Reactor. And that will be in the next release, which will happen early next week, I guess. And I will try to show you that. So you hopefully now see the terminal window, right? So it's basically my typical setup, 3 nodes, the Alma 9, 40, 41, and 42 nodes. It currently looks like this. DRBD connected and secondary everywhere. That is because I haven't even started DRBD Reactor, so no services running. Let's take a look at the service we are going to start. So it's a very simple service. It's just one ticker service. We will look into that in a second. And then it has this new setting on quorum loss is freeze. If you don't specify that, then you get the old behavior of stopping the resources immediately. Then let's start DRBD Reactor. And we see it, because it's only running on one node, this node is the one that became DRBD primary and started the service. And as we see, that's a very simple service. It's just a bash loop that prints the date and sleeps 1 second. And in the log, you see every second it prints the date. That's just what it does. And again, we see it prints the date. And if you look at that line, it says active and running. And now we isolate that node. So like we assume that the whole network is gone. In our case, we do that with IP tables. That takes some time. We see DRBD, it's still primary and it lost connection to its peer nodes. And if we look into the service status, then we see it's still active, but it's frozen. And if we take a look at the log files, we see that it stopped printing new log lines because the service is frozen. And in this case, it's just a simple ticker, but in a real scenario, that would be the service that takes long to start. As we haven't started Reactor on the other nodes, no other node will take over. And now we assume the network comes back by issuing IP tables flush. That can take some time. Now nodes are connected back and we see that the service is active and running again because we just unfroze the service and it continued to run. Everything is fine. No, not the ticker. I wanted to actually, and it's now also connected to the last nodes. Everything is good and fine. So that would be the case where network was gone. We froze the old active service. Nodes came back. We unfroze it and continue to serve the service. Probably also interesting case is what happens when other nodes take over. And for that, I have to start the service on the other nodes. So it's active and running on that node. DRBD Reactor now running on all 3 nodes. Then we do the same what we did before. We isolate that node. Same behavior. It's on that node, the service is frozen. But if we check the other nodes, then that's not what we expected, because DRBD should have been primary on one node and the service should have been running. Let's see. Fine, it finally made it. We see on 41, it's now primary. It's connected to 42. Obviously not connected to node 40 because that's the one we isolated. And if we system CTL status, the ticker service. It's active and running on that node because nodes 41 and 42, they had quorum, they were able to start the service, everything is happy and fine there. But we also still have this old 40 node, which also has the resource in primary. And now what happens if we again reconnect that node? We flush it. And that's exactly what we expected. So service was running on the other nodes. They now connected to the old node and forced that node to DRBD secondary. And that was the point in time where we really stopped the services. And that is why we see now that the ticker service is inactive and dead, because it's running on the other node. And DRBD is happy and running. It's secondary on the old node, primary on the node that is now running the services. So all good and nice. Then what I want to show you is what I want to tell you is a few more words about what you actually need to enable, to be able to use the freeze feature. And that is, if you look in the main page of the track. So no worries, we are not going to read man pages here, but the only thing I want to tell you is that there are many prerequisites you need to fulfill to be able to use this freeze support. And that, for example, starts with a relatively new kernel that has support for recent C groups, because for the freeze feature, we use systemd freeze. And even the RHEL 8 kernel is not new enough. If you want to enable the C groups there, you have to give it some flag on the kernel command line. RHEL 9 will work, and recent Ubuntu's, for example, as well. And then you need all these fancy new DRBD options on that resource so that it can deal with getting in contact with the new set of nodes and then getting forced to secondary and so on. And the last thing I want to say, obviously in the perfect world, one would have a more redundant connection between these nodes, but the world isn't perfect, and with freeze we can at least help in certain scenarios where services might take a long time to start and where the network is not redundant. And that's it from my side.
Are there any questions related to what Roland is talking about? If not, we will move on to the next developer.
Yeah, maybe I have a question. There is a DRBD option. It's called auto quorum, which is usually set to suspend IO, and then on node data accessible suspend IO. How are those DRBD options different from the ones we have just seen? Because I'm never sure which of all those DRB options should be set or have to be set, because we just upgraded also to DRBD 9.1.11 and try to use that in Piraeus, but I'm not sure which of all those options have to be set, because when we isolate a primary, we see that the primary still stays primary. However, the HA controller then promotes another resource being primary, and we actually have two primaries. When the isolation is removed or the network connection gets reestablished, then of course the for secondary method or functionality then kills the primary and yeah, makes it secondary. But in the moment of the isolation, you can still write to the old primary disk. So I think there are some DRBD options still missing in our configuration.
The only thing I can add to that is that yes, that's expected because with these settings you still can issue writes, but they will not complete, because that's what the suspend IO does. So from what I heard from your side, I would say yes, expected. And for more details, I hope somebody from the DRBD team can jump in.
Or maybe Moritz, he just released this HA controller, and in the README, only the DRBD options auto quorum suspend IO and on no data accessible suspend IO and on suspend primary outdated for secondary are mentioned. But you just showed the documentation where at least one option is added, and that is on quorum loss suspend IO. Maybe that one is missing.
That is just the difference because you're using LINSTOR, and LINSTOR has this auto quorum option, which it only uses if there's at least 2 or actually 3 nodes involved. And if you only use 1 node, then it doesn't set this quorum option because it doesn't make any sense. But internally it sets the same option as mentioned in the main page.
So on no quorum loss is set automatically on each of those nodes?
Yes, that's
okay.
That's the option that the auto quorum option sets, basically.
Okay, got it. So I will test it one more time. Maybe then we have another problem because the old primary stays can still write to the disk even if it doesn't have any quorum. Maybe another bug. I will check it one more time. Thanks.
Cool. Are there any other questions? All right, so we'll move on. And up next, Gabor is going to talk about LINSTOR ABS features. So Gabor, the floor is yours.
Thank you. So I thought that before I just jump into the LINSTOR stuff, I might give you a brief introduction about what you need to know about EBS and EC2. Just a few quick words, don't worry about it. So we are only using 2 terms, which are EBS, Elastic Block Store, where we have already 2 volumes set up in my Amazon account, namely the root disks for the 2 EC2 instances. EC2 is basically, in this presentation, you can regard it as virtual machines hosted by Amazon. That's basically all you need to know for this one. We have public IP addresses and internal IP addresses or private. We will come back to this part a little later, but what we want to do is to create volumes with LINSTOR, use them, write data on them, and set up a DRBD instance up and running so that we can replicate. Point is, Amazon itself has replication internally, but only within one availability zone. So what Amazon does not do is synchronize between 2 different availability zones. This is what we will use DRBD for, at least in this demonstration. Okay, so let's begin. As you can see, I have not really set up anything purposely. Whenever you start using ABS for anything, the first thing you need is to enable LINSTOR's encryption mechanism with a hopefully more secure password than this, but never mind this. This is good enough for the demo. The next is you need to create a new EBS remote instance. So what we have here is we create a new EBS remote. We call it EBS EUC1A. 1A is for the availability zone. This is the availability zone Amazon uses, so this has to be precisely the availability zone Amazon says you. LINSTOR will figure out the region and endpoint on its own if you do not override it based on this availability zone. This is just my access key credentials. I'm not going to share a secret key. And as I told you before, we want to synchronize between two different availability zones, which means we will have to create yet another EBS remote. This is the very same command, just different availability zones. Okay. So the next is yet another rather interesting or special command, you could say, is we are creating nodes, but not just regular satellites. We are creating so-called special satellites, which only purpose is to represent the storage pool within Amazon without having a satellite running in the Amazon central. I'm not talking about the EC2 instances. Those are different things. We will come back to them later. So we have our node name, which is basically arbitrary, and the EBS remote name we just created earlier. What this command does in the background is it spawns actually an additional satellite instance running beside the controller instance in the same VM. But that special satellite, we call it special satellite because it is configured to not touch the local disk. It only will be used for sending REST requests to Amazon or to whatever. It just pretends that it represents the Amazon storage pool. Once again, we will need two of them because we want to replicate later on. All right. So that's the setup. Usually it should say here satellite, but as I told you, this is the special satellite, which is different node type. This is also pretty self-explanatory that it is running actually besides the controller, so local host from the viewpoint of the controller. Next, we actually want to connect to the two EC2 instances, but we need to do it using the, the external IP addresses of these two. Okay, so I have just copied them already out. This is nothing special. This is just two ordinary LINSTOR satellites. Nothing too relevant here. Right. We want to use the internal network for DRBD replication. So we also need to set up the interfaces and the preferred network interfaces or prefnic property, which some of you might, or hopefully most of you are familiar with. Sorry if it is too fast. I'm just telling LINSTOR to, hey, there is a new network interface on this node. This is the interface name, and this is the internal IP address. Same command for the other node with the other IP address. And now just set this magic property prefnic to use. This is the preferred network interface. This is what we just told LINSTOR. Okay, so actually there's only one interesting command left, which is we need to create an initiator storage pool. So EBS is also using this target initiator setup you also find with NVMe or Exos or other setups. The target itself hosts the disk itself, and the EBS initiator connects to the device and provides the device to higher layers. So for that, we need to create in our EC2 instances, although this is called EC1, but never mind that, EBS initiator storage pools to connect to the actual target storage devices. So let's just create that and hit again 2 times. Okay, so let's see what we have. Right now we have actually 4 satellites, obviously. Okay. So once you're here, you have 2 target satellites. These are the special storage pools that represent the Amazon EBS volumes, and 2 initiator storage pool, which will be later used to connect to those just created volumes. The next 3 commands is rather simple. Just create resource group, volume group, and just spawn a resource from it. Spawn will create 2 EBS volumes once it's done. So refresh this, please. Thank you. So there we go. We have the first 2, one are the root devices, so we just ignore that. And we just have 2 newly created volumes. These are shown as available. They will show in use once we connect to them, so that is our next step. But yeah, we have 2 EBS volumes. And connecting is also fairly simple. We create a resource on 2 nodes. This is the resource name. Just tell them you are EBS initiator and use this EBS pool. Once we do that, we see that on top, we have the DRBD up and running, and DRBD is already syncing. Amazon also says it's in use. Right. LINSTOR also supports snapshots, but for that to demonstrate, I have to wait for the sync to be complete because LINSTOR only allows me to create snapshots from fully synced up resources. And there is one tricky part, namely the snapshot itself was created just as fast as LVM or ZFS would do, but Amazon needs some additional time doing something with the snapshot. I just can't guess what they are doing, but until this snapshot is still pending or in progress or whatever you want to call it, Amazon does not allow to, for example, restore the snapshot into a new resource. So LINSTOR also prohibits that. And as soon as the snapshot is fully processed or processed, this pending state will just disappear and it just becomes fully successful. And from then on, you can do whatever you want to do with it. And I think that's basically summarizes the whole demonstration. Are there any questions?
Everybody got that? That's awesome. All right. Well, up next, Joel is going to give us a summary for DRBD 9.2. So Joel, the floor is yours.
Thank you. I hope you can hear me okay. Yep, so I'm just going to talk you through some of the new things which have come into DRBD 9.2 over the last few months. We've got quite a few features which have been added. So let me show you. I hope.
I think he froze.
Yeah, it appears he did. Do you want to pop to the next and we'll circle back on him once he recovers?
Are you talking about me?
Yeah. Would you be ready, Johannes?
Okay, we can do that. I just found Joel told me that I was called Roland Kamera on the that's why I restarted my Zoom client. Okay, so nothing. Okay. Okay, I do a real quick presentation on what's coming up next. Yeah. Okay. Can you see this slide?
Yes.
Yep.
Okay, great. So we have two exciting software releases from the Windows platform coming up. The one is WinDRBD, the 1.1 branch, first stable release. And the other one, what I was mainly working on this year, is the LINSTOR for Windows. To those who haven't seen the last community meeting, I presented features of LINSTOR for Windows there in more detail and also made a demo. Today, I only want to walk real quick through the new features. So for WinDRBD 1.1, we have finally secure boot support, meaning that WinDRBD also runs on Windows 11, and we expect that newer server versions also request secure boot, mandatory. Don't know if nobody knows if this will happen, but I suspect it will happen. So we are ready for the future on that side. The other thing is that the installer is assigned by Microsoft directly. Microsoft has stopped allowing third-party like DigiCert signatures. So we have to go to a validation process where we fixed many issues on the plug-and-play interface. So it was actually good for the quality of the software. And lots of minor fixes, mostly those are fixes found by LINSTOR integration. There was, for example, one bug where DRBD resources get stuck in negotiating. And this is interesting because it was, I think it was the first real DRBD upstream bug I found after 5 years of developing with DRBD. So probably shows the high quality of the DRBD source. The other thing is LINSTOR for Windows, what you already know. It uses Microsoft storage spaces. It's something similar to LVM, Logical Volume Manager on Linux. Of course, it has WinDRBD support, and we support all Windows Server versions starting from 2012. So if you want to use older server versions, then you have to edit your configuration file manually. Sorry about that, but it wasn't practical because some I think storage spaces doesn't exist at all on Windows Server 2008. So there was some reason for so we cannot support these old versions. Yeah, what will be part of this release is that we can mix Linux and Windows environments. Last community meeting, there was a user who requested this. What we will not include in the first release are things like snapshot support or backup shipping. This requires a little bit more time, but it's also on the schedule, but not for Q4. So yeah, that's all from my side. And if there are any questions, you can also write me an email or ask now. And yeah, see you next time. Thanks for joining.
All right, so if you don't have any questions right now, feel free to send an email to Johannes. But we see that Joel is back. So do you want to take it from the top for your summary of DRBD 9.2?
I will try, and let's see if Zoom crashes again. I'm attempting a different way of sharing my screen. So if you now make my video large, you should see my slide. I hope that's working.
Sorry to interrupt, Johannes, I think you are still sharing.
Yes.
Okay, yeah, I have a little bit problem.
Okay.
Okay.
So now you have to, if you have the gallery view in Zoom, you might see it very small, but otherwise you'll see my slide now, I think.
Is it still shared?
No, Johannes, yours is not shared anymore. It's all great, thanks. So yes, let's see if that works.
Okay. Yeah, I changed the view to speaker. I would
Okay.
advise everyone to do that.
Yeah.
I just changed it so it should spotlight for everybody right now.
Good idea. Yes, so here are some of the new features coming up in DRBD 9.2. So let's start from the top. We have network namespace support. This is mostly relevant for the Kubernetes environment, because in Kubernetes, LINSTOR satellite runs in a container, but until now, DRBD still used the host network interfaces, not the container network interfaces. And this doesn't fit so well with the Kubernetes networking model and cause some complications, such as setting up firewalls and things. And if you're in a hosted environment, then that's particularly complicated. But now with DRBD 9.2, thanks to the work of Moritz, DRBD runs like it's in the container. It's not sort of in the container as the process, but the network interfaces are those of the container. And that fixes these difficulties. So to say it in a slightly more technical way, when a DRBD connection is created from a network namespace, like a container, then the connection that DRBD creates will use the network interfaces on that container from that network namespace. And this means that the DRBD traffic will be transmitted, as it were, along the cluster network rather than the host network. So the next one I've got up here is the RDMA transport. And that's existed for a while, but it hasn't been open source, and now it is. So we can celebrate that, and it makes it available to a much wider audience. Should be treated as a beta for now because it hasn't seen so much exposure in this form. But here is a small demo of a Wireshark capture of a DRBD RDMA connection. So you can see that this is using the DRBD RDMA protocol, and you can see, if you know what you're looking at, that it's the InfiniBand dissector from DRBD, and so on. So that's just to show you what that looks like. And there are RDMA flow control special packets related to RDMA. That works. In that form, what you were seeing was actually RDMA over converged Ethernet, RoCE. But of course, you can also use it with real InfiniBand interfaces. Third up, we've got more effective discard during resync. It's particularly relevant with thinly provisioned volumes, but also with physical devices, and ZFS, CFS. And the point is that these discard operations that we do, the trim or discard operations, can be quite slow, especially if you produce lots of them, because the back end often only processes one at a time. DRBD now combines the requests together so that it sends fewer larger requests, which is much faster. And the fourth one is the less contention between resync and application I/O. And that's actually the biggest change in terms of code, lines of code, I think, of all of these. But you don't see so much of it. It's a low-level change in the way that DRBD handles the resync and application I/O. So when your application or file system is writing, and at the same time you have to resync to appear, usually everything works fine. But if you have a particularly busy application that's writing continually to the same areas of the disk, then that could cause problems with earlier versions of DRBD and cause the resync to go very slowly. And this new solution avoids those problems so that the resync is more reliable and you can get back to your required level of redundancy more quickly. And finally, I have the lower write latency. This is achieved via a different interface in the kernel that avoids an extra switch to another thread. And so if you have a high performance application, especially with Protocol C, then you will see lower latencies, and that can also translate into higher bandwidth depending on how your application is set up. So those are the features I wanted to present, and DRBD is now 9.2 is now quite stable. The latest release candidate has just been released, and we're planning to release this first stable release very soon, probably next week. So any questions to those?
All right, so let's move on to the next section, and that is going to be talking about KubeCon, and RT is going to tell us about that. So RT, you have the floor.
All right. Hey, everybody. We just wanted to have a little plug here for KubeCon. I will be there, as well as Brian and some of our engineers and salespeople from the EU, as well as the US team. Come by for some awesome swag, and we'd love to talk about high performance containerized storage. If we go ahead and turn our gaze over to the amazing Sarah Zimmerling, she has this LINBIT fanny pack, and they are in short supply. So if you do want one, you got to come see us. You got to do it quickly, and we will have them for you. So just wanted to have that little plug, and yeah, come check us out.
Cool. So the next thing we're going to talk about is kind of like an open Q&A for a little bit for anybody who has any general questions related to LINBIT and LINBIT products, especially if you have any questions about the fanny pack. That is definitely going to be understandable.
Yeah, Michael, one more remark on it. There's also a virtual KubeCon, and we are going to send out the join codes and discount codes for this one in the coming weeks.
Nice.
So everyone can join.
All right. I don't see any questions listed in the Zoom with any raised hands, but if anybody has any, feel free to do so. If not, we can move on. So I'll give you a few seconds here or there. See anybody speak up if you have a question. Arun says they have a question in the chat. Says, I'm new to LINBIT. I have questions. Feel free to ask it. You can also type it in the chat if you'd like, and I will repeat it. Can we build a SDS cluster on top of VMs? I have no idea. So
does one of the developers want to chime in on that one? I believe you can do LINBIT SDS within VMs. I don't see any reason why you wouldn't be able to, unless somebody has something different to add.
No, I think it is possible because that's exactly what the vSAN does.
cool.
Yeah, and you can also usually just follow it up in our Slack community. I mean, there we also answer questions.
Yeah, Arun, depending on how quickly you want to get this going, we do have a vSAN out there you can download and go. It's still in tech preview, I will warn you, but we're rapidly approaching a finalized product on that. And if you have any feedback, we'd certainly appreciate it.
Any more questions?
I have a question on the Piraeus implementation. I love that there is the option to use Kubernetes own etcd instead of a separate etcd for maintaining all the resources and configuration. And we are talking about this for quite a while, but I haven't seen progress on that. Will there be a migration from the etcd of Piraeus to the Kubernetes migration using the CRDs? That would be really useful because we have a bunch of clusters already using Piraeus and its own etcd, and we would like to migrate that once this feature becomes stable. Are there any plans on that?
Let me put it this way. It is on my long-term to-do list to implement an arbitrary database converter thingy. So etcd to Kubernetes or to SQL, or one SQL dialect to another one, or whatever you want. I cannot give you an exact date when we are going to release it. It's on our to-do list. We plan it, and this should allow you to migrate from etcd to Kubernetes, definitely.
Okay, and can you quickly say when the etcd in Kubernetes or the CRDs will become stable? Are they already considered to be stable?
In the past times, we experienced a few unexpected performance issues, but apart from that, I do consider them quite stable. There might be a few smaller bugs, but yeah.
Okay, cool.
Do you have any other things to say? You are more in the Kubernetes field than I am.
The only thing I can say is that I'm personally using them for a very long time now, and I haven't had any unrecoverable problems up to now, and actually no problems since, I don't know, 6 months. So that's that. But of course, that's only my personal test system.
Okay, so you definitely would give it a try also for a production environment.
Yes, definitely.
Okay, that's great. Then we only need to solve the migration path for us.
All right, great. There's any more questions? All right. So thank you everyone for coming to the LINBIT community meeting. If you're listening later on YouTube and have any questions, feel free to leave a comment on YouTube or join the Slack. And for now, thanks again for coming to the LINBIT community meeting. And I hope you enjoyed it. And I hope you found it useful for information about the LINBIT and all the awesome software that we have.